At CircleCI, as a result of the product that we deliver to our customers, a CI and CD platform, we spend a lot of time thinking about removing what we refer to as undifferentiated heavy lifting, meaning all of the things that our customers do in order to get their customer value into the market that isn't specifically tied to that value. All of the automation and process and tooling and infrastructure that's required to deliver their software that isn't necessarily the software itself. And so we don't just think about that in terms of the product that we deliver to our customers, but we think about it in terms of how we deliver. And so today I want to talk a little bit about reducing that heavy lifting from our process, some of the things that we've tackled. And in order to do that, you need to understand just a little bit about what we at CircleCI do. So we're a CI and CD platform, as I said, and we serve a little over 800,000 developers. We're coming up on 2 million builds a day on our platform, and that's in support of about 30,000 or so organizations. But it hasn't always been this way. CircleCI was founded in late 2011. The product was initially launched in early 2012. And like so many startups, when we first launched our platform, it was very simple. The architecture looked a little bit like this. It's one of my favorite architecture slides to use because it describes so many common systems out there. And we only provided this service to what we called our cloud. Well, we didn't call them cloud customers at the time, I guess, but they were what we now call cloud customers, meaning we also have a product that we call our server offering that we allow customers to take and install themselves, operate within their own environment, maybe that's their own cloud or a public cloud, but partitioned in their space, or in their own data center on their own premises, many different variations. And in order to get there, we needed to do some thinking about how that could work. So the product is cloud native. We started out only operating again in an AWS environment, and we wanted to be able to support not just multiple installations of that, but the tools that go with it, and do that across multiple different environments depending on what the server customer needed. And even though we had a monolith at the time, there were a few supporting services. So there were the data stores where we actually have caching or state of jobs run, users, preferences, settings, those sorts of things, as well as some additional services. So for example, we use Pusher to manage WebSockets in our cloud environment. That wasn't available to all of our customers on the server side, so including something that supported that capability. So small number of services, fairly easy to coordinate, but still needed to be managed. And so we went in search of something that would help us do that. We also had needs around license management, upgrade paths, and the actual managing the delivery of our software into the customer's environment. We settled on a solution called Replicated, which is a third-party vendor. And that vendor provides a lot of those things I described, license management, upgrade path, actual management of the software lifecycle. But they also happen to include in that packaging an orchestration engine. Now at the time, we were running our cloud environment without containers. We baked AMIs or basically built AMIs that represented the majority of what we needed, deployed software updates onto them, and actually spun up brand new instances with new versions of software, but updated with the currents, basically deployed that additional software onto that AMI once it was spun up, or that instance. So no containers involved. We were actually using LXC and containers to manage the jobs that we were executing for our customers, but our software was not running inside of a container environment. So this was our first foray into Docker and containerizing our application, but again, it was fairly straightforward. A monolithic application of our own, plus a few services, database, pusher replacement, a couple other things. And so Replicated was perfect for that. But then we continued to grow. So this is 2015 when we first launched our server offering, and we were also scaling significantly in our cloud environment. And in order to handle some of that scale, we started to break apart our monolith into multiple services. So not just many different small services handling specific capabilities like our API or workflow coordination, but also multiple instances of our monolith that were configured to do different subsets of the work, which helped us from an operational perspective in scaling. And in order to handle that in the cloud environment, we started to go past what was reasonable for us to do with our sort of homegrown deployment model. Well, our deployment model is based on CircleCI, but the sort of orchestration of those pieces became more complex. And in order to manage this proliferation of services, we realized that we needed to do something different. And based on the timing and what we were seeing with respect to success in the market, the community that was evolving, we settled on using Kubernetes. But like so many great solutions in software and technology, now we had two problems. So we had a replicated solution, which was great for our server customers, or at least great with the small number of services that we're using for our server customers, and separately, Kubernetes-based deploy for how we were managing things in our cloud environment. And because we have a distributed system with very complex interactions, we really had more like n-squared problems, meaning every single thing that we did across all of those services needed two solutions. So we had configuration management, secrets management, the actual deploy model needed to be solved twice for every complex solution we had. The communication path between systems, everything was duplicated. And this, as you can imagine, led to a large number of challenges for us. And some of the stress of thinking about that can be relieved by looking at some cute animal pictures. But more importantly, I want to look back at the principles that we fell back on to try to think about how to solve this problem. And a lot of them evolved out of effectively the patterns that we had seen through the creation of the DevOps movement, and specifically developers and operators working effectively together, learning from each other, sharing that knowledge, and building better ways of doing things. So I think in order to get there, it's useful to go back and look a little bit about how that evolved. So prior to DevOps, if you were around at that time, we had developers who would write software, maybe package it, probably just finish writing the software and leave it in source control. And then operators who owned a production environment, and what I often refer to in between as the chasm of despair. Developers didn't want to deal with trying to get something into the production environment. Operators didn't want developers to change their environment because they knew it was stable, and they didn't want to deal with the repercussions of all that change. There was a lot of risk, or perspective of a lot of risk. Changes were slow and big, which increased risk, and things were fundamentally broken. And the first bridge that was built in there was really sort of CI and a clearer sense of smaller increments, both, I guess, starting with agile process and building in smaller increments, and then making sure that stuff was well integrated and validated and tested, and then handed over to the operators of the production team. So that was a big early step. But then a more important step that came along was really starting to shift how we thought about even ownership of these element or layers of the stack that we were delivering. So developers own the application layer all the way through to production. So it wasn't about these vertical slices, or I guess it wasn't about these slices in terms of I own development, you own production, but rather I own this layer of the stack, which is the application layer for an application developer, which goes from actually writing the code to delivering it, and then owning it in a production environment, carrying the pager, being responsible for monitoring and operation of it. And then kind of in an SRE world, owning infrastructure, but owning that in a way that looks like the way that we own application development. So using an infrastructure as code model, working on very clear management of change, validating and testing those same changes, and then pushing those out into production, but at the infrastructure layer, and then owning, again, pager duty, or carrying the pager, having responsibility for the effective operation of that infrastructure layer. And so there's a lot of opportunity to look at that now and see how we can learn again from that. This particular picture is a little bit old now, but a joke that was put together by our country manager in Japan. And this is myself and our CEO. And the CEO is wearing a t-shirt that says, "I completely understand CircleCI." I'm wearing a t-shirt that says, "I can do CircleCI a little." And the humor in here is about people who learn more and grow more, realizing how little they know. And this, going back to the previous image, is really a great example or a great sort of reference to what we all learn from each other. So recognizing all of a sudden that as a software developer, an application developer, I don't really know what goes on in the world of operations, but if I actually take the time to sit with and work with those folks, I will be better at doing my job, and I will be able to understand more about how an overall system can work and how I can build software to work effectively in that world. And vice versa, from an operator's side, recognizing, hey, if I take some of these traits of how software developers have been building, I can use that to create a better, more robust infrastructure layer, and recognizing that we have a lot to learn from each other. So now I want to take that and look at how we approach the problem of managing our server installation and what we took away from that. So we learned 4 basic things in here that I want to talk about. 1, understand your customer, who they are and what they really need from you. 2, focus on your own core competencies, as I discussed a little bit at the beginning. 3, use abstractions in order to isolate change. And 4, use abstractions to reduce your complexity. So first, about understanding your customer. This is Maya, Jenny, Dante, and Diego. And there are 4 personas that we use at CircleCI to get a real crisp picture for all of us about who the customer is that we are trying to talk to and that we are trying to build our product for. And having this sense of who your customer is really valuable as you start to think about the kinds of capabilities that you want to provide and how you want to provide those capabilities. So a quick look at who the CircleCI server customer is. First of all, anybody that is taking our application and running it on their own, in their own environment, managing it by themselves, is a fairly sophisticated development shop. If you are in a position where using our cloud environment is not going to be the right solution for you, it's quite likely that you have a team of folks responsible for managing and supporting the tooling of your software development team, folks who are specifically responsible for ensuring that developers themselves are productive. And so you have a lot of skill and capability in your shop. You probably have experience with Kubernetes, especially at this point in 2020. Kubernetes has become the dominant tool in terms of orchestrating many production environments. If you're operating at the scale where it makes sense for you to be running our server product, you're probably operating at the scale where you have a large number of teams and a complex production environment. And so using Kubernetes is a skill that you will have already. You'll be more concerned with quick upgrades, maybe upgrades of incremental components, than you are with a simple one-click install. So one of the things that we learned operating the replicated version of our product is that it's very simple to get up and going, and that's very helpful for certain types of customers, but they're not the core customer of CircleCI server as we now know it. And so we were leaning towards a specific type of customer. Well, in fact, we were leaning, or we were not leaning. We were spread across a broad spectrum of customers, from customers who needed a very simple one-click install with one-click upgrades, to customers who have a large number of developers depending on them at any given time, and have the sophistication and the experience to be able to run a platform at scale, and just needed us to provide them with the right tools to do that. And along the same lines, the product, when used in one of our large server customers, looks a lot more like the multi-tenant cloud that we run, meaning there's many disparate teams with disparate needs, and then a centralized team that is operating and supporting all of them, rather than sort of a small work group kind of setup. And so the capabilities that we use in our cloud environment are much more valuable to those customers than a customized, streamlined, simplified server installation that looks more like a simple piece of packaged software. Focus on your core competencies. So one of the key learnings that we've had just as a software development organization, but applies to how we think about deploying and installing software and other things, is that the key value that we can deliver is the value that our customers see every day in the product offering itself. And the things that we do that are tangential to that, I talked earlier about undifferentiated heavy lifting, are effectively a waste of our time. And so one of the best views, I think, for me personally, of how to think about this kind of your core competencies is domain-driven design. This is a book by Eric Evans. There are other authors who have written on the subject subsequently, some extensions of his original thinking. Any of that content is useful content to absorb, I think. And the key focus in domain-driven design is really around breaking apart the complexity of your software. And one of the early processes that you go through as you start to think about this is recognizing, unsurprisingly, your overall domain, but then breaking that down into subdomains. And as you go through that process, one of the things that you notice is basically splitting apart what Eric Evans refers to as your core domains from generic domains, or in some cases supporting domains. So looking at CircleCI in particular, this is what our domain effectively breaks down as. So at the core, we have two main subdomains: workflow coordination, which is identifying work to be done, breaking it down, and ensuring that the individual jobs are handed off to an execution engine, and then job execution itself, which is finding capacity in the system and ensuring that the job gets run correctly and that the results are actually then transmitted back to workflow coordination and other subdomains that are dependent on that information. Around the periphery, we have things like operation, post-processing, which is taking log streams and pushing it to other locations, managing identities and permissions, etc., which in many cases are somewhat generic, meaning, let's take plans and payments. There are very few people who are excited to use CircleCI just because of the way that we charge their credit card. They're there because we do the core work for them of validating change, ensuring that what they've delivered or what they're working on is good and can be delivered into a production environment. They just happen to pay us for it, and they're totally comfortable with that, but that's not what really differentiates us. So those sorts of subdomains are places where we can look at taking tools off the shelf and focusing on the core. However, it's also possible to zoom in another level and see something slightly different, or see the same patterns actually break down again. So for example, if we look at that job execution section, or job execution subdomain, which is absolutely core to us, you can see that there's a breakdown within that domain. So environment construction, which is how we put together the pieces to make sure that it looks just like your production environment, signaling in and out in terms of how the job should get run, what the status is. Those things are very core to what we do. But overall task scheduling, for example, is somewhat generic. We actually tried to build our own a task scheduler. We did in the early days, but as we scaled, we realized there were other people out there who had done task scheduling well. Now, this is the tasks that we execute, or the jobs that we execute within our environment for our customers, not the orchestration of our own services. But even that is something that we can take off the shelf, and that is built much better than we would build it. And we know that because we've tried. And that allows us to focus our energy on the things that really differentiate us. Going to the other end, operation, for example, container orchestration now in terms of orchestrating our actual system, observability. These are solved problems. There's tools out there that I can take off the shelf and use for these. But upgrade and the manner in which we upgrade our services in order to ensure that they work really effectively and support the needs of our customers is core to what we do. And so we can focus our energy very tightly on that specifically. So now let's talk about isolating change. One of the challenges that I think we all have in this industry when we try to use tools off the shelf is we tend to go all in, meaning we choose a particular tool and then we bake the knowledge of that tool deep into our systems. And as a result, we greatly increase the cost of change. Now, there are many folks have done a lot of good thinking about how to build systems in a way that effectively inverts that relationship and makes tools or frameworks that we use feel like libraries effectively, and allows us to insulate ourselves from that. This is a simple representation of something that's, in this model referred to as hexagonal architecture, but many folks have been thinking about this. Ports and adapters is another similar architecture, which looks very analogous to this, with a concept of basically taking adapters and using those to represent and abstract ourselves away from the decisions that we've made. So on the left, you have driving adapters, which is mostly input. And take an example here, like an HTTP API. Maybe today I want to use JSON over REST, and tomorrow I want to use GraphQL. So separating that out in a way that means nothing inside my application or domain logic understands that I have chosen REST or JSON allows me to make that decision or that change much more quickly. And I think we've had some of these concepts in the past, but looking at the right, so for example, on Postgres, historically we've thought about things like ORMs, but that concept glues me still to the choice that I've made, which is a relational database. And when I go, there's no real ORM in a NoSQL or document database world. And so I haven't actually abstracted myself from the right problem. Like in theory, I can change between MySQL and Postgres, but mostly what I've done is eliminated my ability to use the best tools in one of those environments by trying to make it generic. And I haven't actually insulated myself from what is a more likely architectural change, which is for this particular piece of data, I would be better off storing it in a document database or a graph database or a cache of some kind. And the types of changes that I have to make I'm not insulated from them when I have an ORM at that layer. So looking specifically at some of the tools that we've chosen, again, we actually do use Postgres, although we've gone the opposite direction from Mongo and having a lot of basically everything in a document store to partitioning that out and using relational databases for some things. Kubernetes, which was in the server environment, has been replicated, but orchestration in general and our need to actually manipulate how orchestration is working. And then we need access to clouds, both because we scale capacity in order to run jobs, but also to do things like store artifacts and data coming out of builds in a generic way so that we can deploy across multiple places. And JClouds, for example, is a Java library that abstracts me somewhat from those things. GoCloud, similar in the Go world, but I want to put myself a layer above that by basically saying this is storage, this is deployment, this is scaling, and I don't really care which tool I've chosen. So when the creators of JCloud stop really focusing on that, and there's a different tool that we think is appropriate, we can protect ourselves from that. And so going back to this model, this is effectively isolating the application layer and the domain logic from all of this infrastructure in a way that makes it much easier to make those changes down the road. So finally, let's talk about using abstractions similarly, but to reduce complexity. I read this book a couple years ago now, Philosophy of Software Design by John Ousterhout, and there were many great concepts in there. And in terms of specific implementation, some things I agreed with, some things I didn't. That's totally fine. But I think the underpinning or overarching idea that he presents in this book is really critical, which is that our job as software developers is to try to contain and minimize complexity in our systems. And I love this quotation: the greatest limitation in writing software is our ability to understand the systems we are creating. So one of the really interesting things about software compared to many other engineering disciplines is the lack of constraints. I mean, we basically have a text editor and our skill and imagination. I think it's actually one of the reasons that we end up building so many things ourselves and doing undifferentiated heavy lifting, is because we know we can, it's always achievable, and we're not limited by constraints. By comparison, if I'm building a skyscraper or a bridge or sort of a civil engineering project like that, I'm generally surrounded by constraints, whether it's everything from legal sort of requirements, codes, to physical location, the structure of the soil, whatever that might be. And so the thing that ultimately ends up being the boundary or the constraint from a software perspective is just our ability to understand the system. And as a result, we need to be very focused on minimizing and reducing complexity. And one of the ways that we can do that is by pushing things behind abstractions in a way that we can think about the piece that is relevant to us and have a clear set of abstractions that represent other components of the system, so we don't have to dive into those layers and understand them. And so if you look at how we have built our server product with CircleCI running inside of a replicated environment, replicated itself effectively became part of our application. So as we deliver the application to our customers, they have to understand that full stack of complexity, which is everything that we do plus everything that replicated does. And as we build it, we need to think a lot about that interaction and basically treat it as if it's an extension of our application, because that's how we're delivering it to our customers. So by shifting the orchestration engine to be one that is consistently understood by our customers and consistent with what we use, we basically cut the footprint of our application in half. It's not really half, but in this diagram it's half, meaning the only thing that we have to worry about is how our application runs, with Kubernetes as effectively the abstraction layer over the many different clouds that we can deploy to, both the clouds that we use in our own cloud environment. So our cloud offering runs on top of AWS plus GCP, or the clouds that our customers want to deploy into, AWS, GCP, Azure, or even again on-prem, as long as they have a functioning Kubernetes environment in which to execute our application, we don't actually need to know or care about what's sitting underneath that. And so again, it effectively cuts the complexity of our application in half, because we're not thinking about this additional layer. Similarly, Replicated themselves have recognized that they were bringing to the table an orchestration engine to meet needs that existed in 2014, 2015, but don't really exist anymore. And have been able to separate their application from the orchestration itself, meaning that the components that are still of value to us around license management, customer management, upgrade, etc., can still exist and be helpful to us, so that we don't have to think about building that and can focus on our core competency. But they can do that using Kubernetes as an abstraction away from all of the challenges of orchestration, and can minimize and focus on their core value, which is, again, that user management, upgrade, licensing, etc., that allows them to be a great value to us, but separates out the core component of container orchestration, which is now well understood and manageable within the Kubernetes environment. So just to recap the takeaways. First, understand your customer, understand what it is that they really need and what they're looking for from you, and honestly only provide that. Don't spend a lot of time making simple or simple approaches to things that don't help them, because that takes a lot of your time. Focus on your core competencies, so pull apart the pieces and find pieces off the shelf that support what you're trying to do, but are not the core of what your customers are looking for from you specifically. Use effective abstractions to isolate change. So as you go through these changes, as the world around us evolves, you want to make sure that your software can continue to take advantage of the things that are out there without having to be remodeled or restructured. And then additionally, use abstractions to reduce complexity. So pull yourself away from all of the things that are challenging and difficult to keep in your head and may or may not necessarily be in your system. So within your system, break apart those pieces so you only need to be thinking about one at a time. And then going back to core competencies, pull in solutions to some of the complexity that you don't even need to build yourself. And that allows you to shrink down everything that you need to reason about in order to best deliver your software. Thank you.